Hi, welcome to this session of the Medication Mathematics course. Today we will be talking about weight-based calculations. The amount of medication desired to elicit a therapeutic response differs from person to person, largely because we are all made differently. That is, we have different body types, we have different weights and heights, we have different genetics, and different metabolism. Some people metabolize medications quickly than other people, and so they are going to need different dosages to be able to have the same response. For some medications, weight is particularly important in ensuring that clients receive adequate medication for therapeutic response, and also to avoid an overdose which will result in adverse reactions or adverse effects. When we as nurses are administering weight-based medications, there are two things that we have to keep in mind. We have to always make sure we have the most current weight of the patient. This will prevent us from making medication errors by giving an underdose or an overdose. We also have to review the therapeutic range for dosing for that particular medication, and this may be based on the weight of the patient or the age of the patient, such as in pediatrics. We can give a weight-based medication through the different routes that we talked about. So we can give it orally or PO in the form of liquid oral solution, caplets, tablets, pills, capsules. We can also give it intramuscularly or IV, such as liquid injections or intravenous infusions. Whichever route that we are giving the medication, to calculate the right amount of medication, we have to know the prescribed dose, the client's weight. We also have to know the therapeutic range to make sure we are giving a safe dose to the patient. At the end of this session, I expect you to be able to convert weight from pounds to kilograms easily, and then to also calculate drug dosages using weight in pounds or kilograms, whether it's milligram per kilogram or microgram per kilogram. Then determine if dosages are safe or unsafe using the therapeutic range that is provided to you. And also to determine if the dose is adequate enough to elicit a therapeutic response. For our rounding rules, we are going to round up anything that is greater than 1 to the nearest tenth, and anything below 10 and below 1, to the hundredth. And so that will be 2 decimal places. So if it's greater than 1, you are going to round it to 1 decimal place or to the 10th, and then if it's less than 1, 100th or 2 decimal places. Let's begin by doing some weight conversions. Question: convert the following weight to kilograms. A, 44 pounds. The first question we should be asking is, what is the equivalent from kilograms to pounds? So we know that for every 2.2 pounds that we have, we are going to get 1 kilogram, right? So what about if we have 44 pounds? What will be its equivalent in kilogram? That we don't know, so we will say X. Let's do our cross multiplication. So we are going to end up with 44 pounds times 1 kilogram divided by 2.2 pounds. And this will be equal to X, which we want to know. So pounds will cancel pounds, and what we have left is kilograms. And 44 divided by 2.2 is going to give us 20 kilograms if we do it on our calculator. So let's do that and then see. So we have 44 divided by 2.2. That is equal to 20. Okay. All right, let's do B. Now we have 12 pounds and 8 ounces. So we have different levels that we have to convert. So first of all, let's convert this ounces to, so we have 12 pounds. This kind of sketchy. 12 pounds and then 8 ounces. Okay. So how many ounces in 1 pound? We know that for every 16 ounces that we have, that is equivalent to 1 pound. What about if we have 8 ounces? What will be its equivalent in pounds? That we don't know, so let's do that and then cross multiply. This means that we are going to have 8 ounces times 1 pound divided by 16 ounces, and this is going to give us 0.5, because 8 will go here, 1 will go into itself, 2. 1 divided by 2 is half, and that is 0.5. So you have 0.5 pounds. Now that we know our pound equivalent for 8 ounces, what we will have to do is add that to our pounds. And so we are going to end up with 12.5 pounds. Now we have to convert this to kilogram that we don't know, but we know that for every 1 kilogram there is 2.2 pounds. So we have 2.2 pounds equals to 1 kilogram. Let's do our cross multiplication, and we have 2.2x equals to 12.5 times 1 kilogram. So when we divide each side by x, then we are going to end up with 12.5 pounds times 1 kilogram, all divided by 2.2 pounds. So pounds will cancel pounds, and now we have 12.5 divided by 2.2. So let's bring up our calculator and do 12.5 divided by 2.2. That is going to give us 5.681818. So those are going to be repeating values. Okay, So let's 5.6818. And when you are calculating for your weight, I encourage you to leave your answer to at least 4 decimal places. Otherwise, it's going to skew your calculation. If you have a calculator that has a memory, store your answer in the memory and then use it. But you will probably not have a calculator that has a memory when you are taking a quiz. And so make sure you leave your answer for the weight to at least 4 decimal places so that your calculation is not skewed. All right, so our final answer is 5.6818 kilograms. That is our final answer for B. All right, now let's do C. So for C, we have 68.5 pounds. So we know that in each 2.2 pounds, we get 1 kilogram. What we don't know is if we have 68.5 pounds, how many kilograms should we expect? So we will say X, and then we will do our cross multiplication, and so we are going to have 2.2 pounds times X equals to 1 kilogram times 68.5 pounds. To solve for X, let's divide each side by X. To solve for X, let's divide each side by 2.2. So 2.2 pounds and then 2.2 pounds. So pounds, 2.2 pounds will cancel 2.2 pounds. And now we have X is equal to 1 kilogram times 68.5 pounds divided by 2.2. So let's do our division. Let's bring our calculator up. 68.5 divided by 2.2. And we have 31.136363. So we have some repeating values also. So our answer is going to be 31.136 36. So we can leave our final answer to 4 decimal places, and so we are going to count after the point. 1, 2, 3, 4, and 3 is our 4th decimal place. So the number after the 3 is greater than 5, and so we are going to round this up by 1. So our final answer is going to be 31.136.4 kilograms. This is going to be our final answer. And so to convert weight from pounds to kilograms, we have to know that there are 2.2 pounds in 1 kilogram. And if we have a figure like we have in B, so let's go back to B, we cannot just say, okay, 12.8 pounds. So if we say 12.8 pounds, let's see, if we simply divide 12.8 by 2.2, we are going to get 5.8181, which is going to be 5.8182. There is a big difference between 5.8 and 5.6, and that is going to skew our calculation. So we have to first of all convert the ounces to pounds, add it to the weight in pounds before we convert to kilograms. Now that we have worked through some weight conversions, let's do an example of a weight-based calculation. A client has a prescription for Tylenol orally, 20 milligrams per kilogram per day in 3 divided doses. The client weighs 22 pounds. The nurse chooses Tylenol with the drug label on the next slide. How many milliliters would the nurse administer per day and then per dose? So first of all, let's look at what the nurse chose. And we see that in this drug label, we have 160 milligrams per 5 ml. All right, so let's write down what we have, the variables in this question. We have our prescribed dose, which is 20 milligrams per kilogram per day. We have available to us 160 milligrams in 5 ml. That's what we have. This can also be written as 160 over 5 ml. And then our weight is 22 pounds. So the first step will be to convert from pounds to kilograms. And so let's go ahead and do that. So our weight is 22 pounds. We don't know its equivalent in kilograms, but we know that for every 2.2 pounds, we have 1 kilogram. Okay, so if we cross multiply, we are basically going to have x equals to 22 pounds times 1 kilogram, 1 kg, all divided by 2.2. So as you can see, 22, 2.2, they kind of look similar by a factor of 10. And so this is going to give us 10 kilograms. We can confirm that with our calculator. So let's see. 22 divided by 2.2, and that will give us 10 kilograms. So that is our weight. So we have our weight under our belt. And then once we have found the weight, the next step will be to find the dose per weight. So we know our weight is 10 kilograms. And then our ordered dose was 20 milligrams per kilogram per day. And so we are going to multiply this by 20 milligrams per kilogram per day. Okay, so kilograms will cancel kilograms, and this means we are going to have 200 milligrams per day. And then the question says, how many ml would the nurse administer per day and per each dose? So now that we know this is our prescribed medication per day, so we can use this to calculate for the ml per day. So we have 200 milligrams per day. This is our prescribed dose. But then what we have is for every 5 ml, we have 160 milligrams. So this is using the formula method or the proportion. So milligrams will cancel milligrams. Okay, we can cancel some zeros, and we have 20 times 5 divided by 16, so that will give us 100 divided by 16. So let's confirm that 20 times 5 equals to 100. 100 divided by 16 is going to give us 6.25. 6.25 ml per day. Now, remember that our rounding rules said that we should convert anything that is greater than 1 to the 10th. So we will look for 1 decimal place after the decimal. So this will be 1 after the decimal, and that is 2. However, the number after 2 is 5, equal to 5. And so we are going to round this up, and we are going to get 6.3 ml per day. So this is our dose per day. The question says that we should also find the ml per dose. So we have to ask ourselves, how many doses? It says in 3 divided doses, or 3 times daily, which means that once we find our dose per day, we can simply divide this by 3 to get the per dose. So 6.3 ml divided by 3 doses is going to give us, so 6.3 divided by 3, 2.1. And this is going to be per each dose. Okay, so this is going to be our per dose, and then this is going to be our per day dosages that we will give to the client. Let's go ahead and do the same example using ratio and proportion. So this is just going to be our setup. Our desired dose now becomes 200 milligrams. What we have is 160, and the vehicle is 5 ml. So using the formula ratio proportion, we have H is to V equals to D is to X. And solving for X, we are going to have this setup, so Hx equals to Vd, and X is equal to Vd over H, sorry. And so H is what we have, D is the prescribed or desired dose, and then V is the vehicle. Okay. So you are going to have 200 milligrams over 160 times 5 ml, and that will be 6.3 ml per day. Let's do another example. A client has a prescription for ibuprofen 4 milligrams per kilogram per dose. The client weighs 69 pounds and 7 ounces. The nurse chooses ibuprofen with the drug label on the next slide. How many mLs should the nurse administer? Looking at this drug label, we note that the concentration is 100 milligrams per 5 ml. So, to solve for the amount of medication we need to give or administer to the client, let's go ahead and write down the variables in this question. We know that our prescribed dose, which we will term as P, is 4 milligrams per kilogram kg per dose. We also know our weight, which is 69 pounds. Write this one. And then 7 ounces. Then we have a medication which is available in 100 milligrams per 5 milliliters. So to solve for the amount of medication, the first step is to convert our weight to kilograms. However, we have to first convert our ounces to pounds. So we know that for every 16 ounces, we will have 1 pound. If we have 7 ounces, then how many pounds do we have, or what will be the equivalent? We don't know that. So let's say that is x. Let's do our cross multiplication, and so we are going to have 16 ounces times x equals to 7 ounces times 1 pound. To solve for x, let's divide each side by 16 ounces. So 16 ounces, and divide this side by 16 ounces. 16 ounces will cancel 16 ounces, and now we have x equals to 7 divided by 16. So let's use our calculator to do that. And we are going to obtain 0.4375. After we have our ounces converted to pounds, then we add this to the pounds. So add this to 69, and now we will have 69.437.5 pounds. Let's write it well. 69.437.5 pounds. Okay, so now we have our weight in pounds, but we cannot use it yet. We have to convert that to kilograms, and so we will set up our proportion the same. We know for every 2.2 pounds we have 1 kilogram. What about if we have 69.437.5 pounds? We will say that will be equal to x. So if we do our cross multiplication, then we are going to have x equals to 69.437.5 times 1 kilograms divided by 2.2. And so let's see what that will give. Our 69.4375 divided by 2.2. That is going to give us 31.5625. And as I mentioned, you want to leave your weight to at least 4 decimal places so you don't skew your calculations. Okay, so this is our new weight. Once we have the weight, then what we do is we are going to multiply our weight by the prescribed dose. So we know the prescribed dose is 4 milligrams per kilogram per dose. So let's do 31. So we have, oh, come on. we have 31.5625 times 4 milligrams per kilogram per dose. So multiply this by 4 and we have 126.25 milligrams per each dose. So this now becomes our new desired or prescribed dose that we are going to use to calculate for the amount of mLs. Okay, so let's use the formula. We have our vehicle times the desired dose divided by what we have. And so this is going to be, our vehicle is 5 ml. What we desire as we calculated is 126 0.25 and then we have 160 milligrams. So milligrams will cancel milligrams, and what we will have is times 5 divided by 160, 3.945. So using our rounding rules, we will round to 1 decimal place, and so this will give us 3.9 mLs, and this will be our final answer, 3.9 mLs. That is what we will administer per each dose. Okay. Now let's consider some safe dose calculations. Remember, we said we will have to compare this to a therapeutic range. So let's do an example. A client who weighs 68 pounds has a prescription for azithromycin 350 milligrams daily for 3 days. The therapeutic range for Zithromax is 10 to 12 milligrams per kilogram per day. Is this dose therapeutic, and is the dose safe? So for a dose to be therapeutic, it has to meet the minimum therapeutic threshold. So when we look at this therapeutic range, we see a lower number, which is the lower limit, and an upper limit. For the medication to be therapeutic, it has to at least be equivalent to the lower limit, and it has to be within the range for it to be safe. If it goes above the upper limit, that is unsafe. That will be our criteria. So let's solve this example. How do we note if this is safe or not? First of all, we have to convert our weight to kilograms. So we note in the question that our client weighs 68 pounds. Okay, so we know that the client weighs 68 pounds, but we don't know what the equivalent in kilograms will be. However, we do know that for every 2.2 pounds, we have 1 kilogram. So by dividing 68 by 2.2, we will get our equivalent. So 68 pounds divided by 2.2 pounds will give us the equivalent in kilograms. So 68 divided by 2.2, that is 30.9091 kilograms. Okay. Now we have to calculate for the prescribed dose. So our prescribed dose was 350 milligrams daily. And so let's go ahead and note that our P is 350 milligrams per day. And we know that our therapeutic range is 10 to 12 milligram per kilogram. So let's calculate for the dose range using our weight to see if we are going to have a safe medication. So what we would do is multiply our weight by the lower limit. So we are going to have 30.9091 kilograms multiplied by 10 milligrams per kilogram per day. Okay, and so this will give us 309.1. We can leave this at 1 decimal place, milligrams per day. Then we multiply our weight also by the upper limit. So 30.9091 kilograms multiplied by 12 milligrams per kilograms per day that will give us 370 0.9 milligrams per day. So our therapeutic range for this client is going to be 309.1 to 370.9. milligrams per day. What we do is we compare this to our prescribed dose. So we see that 350 is greater than 309.1 but less than 370, which means it falls between the lower and upper limit. So we can say that this medication is safe because it's not greater than the upper limit, and it's also therapeutic because it's greater than the lower limit. And so our dose is safe and also therapeutic. Okay. Let's do another example. A client who weighs 22 pounds has a prescription for 150 milligrams of amoxicillin PO 3 times daily. The recommended therapeutic range for amoxicillin is 25 to 40 milligrams per kilogram per day. So remember that the prescribed dose is 3 times daily, that is per dose, but the therapeutic range is per kilogram. So let's solve for this question. We know that our client weighs 22 pounds. The first thing we have to do is change this to kilograms. And now you should have realized that to convert from pounds to kilograms, all you have to do is divide this by 2.2 pounds. And so this is going to give us 10 kilograms. Now, we know that the prescribed dose is 150 milligrams 3 times a day. So to get the daily dose, we have to multiply 150 per dose times 3 doses. And this will give us 450 milligrams per day. So the client is receiving 150 milligrams 3 times a day. So the total for the day will be 150 times 3, which will be 450. And now we have to determine if this is safe. So we know that the upper limit is 40. And so let's see if that is greater than that. So we are going to multiply our weight, which is 10 kilograms, kg by the upper limit of the therapeutic range, which is 40 milligrams per kilogram. So kilogram will cancel kilogram, and we have 10 times 40, which is 400 milligrams per day. This is also per day. Then we have to compare this prescribed dose with this recommended dose range, upper limit. And so we can see 450 is greater than 400. This means that the medication dosage is not safe because it's greater than the upper limit of the therapeutic range. So this is definitely not safe, and we will not give this to the patient. Okay. So I want you to solve this example. This is combining all that we have studied in this session, and I am going to post another video with the solution to this problem. Thank you. I will see you on the next session.